Measuring the rate of reaction. Consider the reaction that we saw earlier. The reaction rate is the rate of decrease in concentration of the reactant with respect to time, or the rate of increase in concentration of the product with respect to time. The reaction rate can be determined by measuring the concentration of the reactants or the products at specific time intervals. The reaction stops when the reactant is used up completely. Observe that the reaction is fast initially, indicated by the gradient or the steepness of the tangent at time t1. The rate of reaction is highest when the concentration of the reactant is highest. As the reaction proceeds and the reactant gets used up, the reaction rate slows down. The gradient at time t2 is lower than the gradient at time t1. When all the reactant atoms have been exhausted, the gradient of the curve is zero. The concentration does not change. If there are two reactant species in a chemical reaction, the rate of reaction will become zero when the limiting reagent is used up. The reaction rate can be measured by different experimental techniques. Measurement of volume of gaseous products at regular time intervals as the reaction proceeds. Measurement of mass of reaction vessel at regular time intervals as the reaction proceeds. Measurement of time taken for a precipitate to reach certain turbidity. Turbidity is the cloudiness of a fluid that contains particles suspended in a liquid. Measurement of color of the reaction mixture using colorimeter. Let us understand each technique briefly. The volume of a gaseous product of a reaction can be measured by collecting the gas in a gas syringe, whose plunger is free to move. As the reaction proceeds, the gas that is produced pushes the plunger out. The volume of gas in the syringe is measured at regular intervals of time. The plunger stops when the reaction stops. The volume of gas can be plotted against time. If a product of a reaction is gaseous, the mass of a reaction vessel can be measured as the reaction proceeds. The gas escapes the vessel, but the solid and liquid products and excess reactants remain in the vessel. The mass of the vessel can be plotted against time. If the reaction produces a precipitate, the solution will turn turbid or cloudy as the reaction proceeds. A mark made on a sheet of paper, placed underneath a conical flask, will be clearly visible initially. As the reaction proceeds, a precipitate is formed, which makes the reaction mixture turbid. The mark will gradually become less clear. The time taken for the mark to be completely hidden by turbid mixture is noted. Here the average reaction rate is obtained. If a reaction produces a product whose color is different from the reaction mixture, the intensity of the color change can be measured using a colorimeter. The colorimeter measures the amount of light absorbed by the solution at regular intervals of time. This amount of light absorbed by the solution can be related to the concentration of the product in the solution through calibration, and the rate of the reaction can be obtained. In each technique, we measure some perceptible change, which is then used to determine the rate of the reaction.
Starting to feel it? Now go master it with Maski.